We are working with the ET55, 14th of November 2015. We are going to be doing question 8 today. So, a 230-volt transformer with a step-down ratio of 19:1 is used to supply electric toys. The transformer has 2,000 turns on the primary. The transformer is rated at 25 VA, ignoring any losses. Calculate the maximum primary current of the transformer. So, we start with drawing our transformer. We know it is 19 to 1. We know it's 2,000 turns on this side. We know in total it's 25 VA. We know it's 230 volts from there to there. Now, we want the maximum primary current. If it is 25 VA divided by 230 V, we get 25 over 30. Interestingly, when it comes to our units, the V's cancel, which is why we end up with amps as our answer. So 25 divided by 230, and we get 0.108, which would round out to 1 amps, which, if we look at the answer sheet, that is what we get. 25 divided by 230 equals 0.11. Now, moving on to the next one. Calculate the number of secondary turns of the transformer. So, what we want to do for this one is grab our 2,000, and then we divide it by 19, and then times that by 1. And that gives us 105 turns. You could, if you wanted to, use the formula that we report, which is Vp over Vs equals Np over Ns, and in our case, our Vp is 2,000. Our Vs is unknown. Our do that correctly. Our Vp and Ns, our Vp was 230. Our Vs is 23. No, we don't get told that. Yeah. They don't actually tell you that, so I wouldn't use that formula. That would be why I didn't use it by default anyway. But the best way is to look at our volts per turn, or our ratio. And ultimately, the ratio is the one that works, which is why we get our 2,000 divided by 19 equals our secondary over 1. That is our ratio, which came from there. And we don't have a volts per turn, but we could if we get our 2,000, and that's what we're using for our next question, which is C. So we have 2,000 divided by 19 gives us 105, but 230 divided by 2,000 gives us a volts per turn of 0.115. Now, if our ratio is 2,000 divided by 19 to give us the number of turns we have on a secondary, we multiply that by 0.115, we get 12.105, so 11 volts. If we look at our thing, they had it at our answer sheet, they had it at 12 volts. So measurement error, rounding error, I should say. Now we move on to the next question. So that's C complete. On D, calculate the maximum secondary current. Now, if we have the voltage, which is 12.1, and we divide the VA by that value, so 25, 25 divided by answer, we will get 2.065, so 2.07. So 2.07 amps. If we look, they had that 2.08 amps. That is a rounding error, as per usual on the exam paper. Now we look at volts per turn on the transformer. We had actually already done that, which is our 0.115 volts per turn, which, if we look back at our answer schedule, is what it says at the bottom.